In this video, we are going to solve a problem that involves Wien's law and conversion of wavelength to energy. Ionizing a hydrogen atom in its electronic ground state requires 2.179 times 10 to the negative 18 joules of energy. The sun's surface has a temperature of about 6000 Kelvin and is composed in part of atomic hydrogen. Is the hydrogen present as hydrogen gas or H plus gas? What is the temperature required so that the maximum wavelength of the emission of a black body ionizes atomic hydrogen? In what region of the electromagnetic spectrum is this wavelength found? This is a question from Donald McQuarrie. Wien's law gives us the relation between wavelength and temperature. We can use Wien's law to find out the wavelength corresponding to the sun's surface temperature of 6000 Kelvin. Then we can convert that wavelength to energy using E equals hc over lambda. If this energy is equal to or greater than the ionization energy of hydrogen atom, then the hydrogen would be present in H plus form. If it is less than the ionization energy, then it would be present as atomic hydrogen. So, from Wien's law, lambda max times temperature equals 2.9 times 10 to the negative 3 meters Kelvin. So lambda max is equal to 2.9 times 10 to the negative 3 over 6000 Kelvin. 4.8 times 10 to the negative 7 meters. Let's find out the energy corresponding to this wavelength. E equals hc over lambda, which is 6.626 times 10 to the negative 34 joules second times 3 times 10 to the power 8 meters per second over 4.8 times 10 to the negative 7 meters. We get 4.1 times 10 to the negative 19 joules. This is less than the ionization energy, which is 2.179 times 10 to the negative 18 joules. So hydrogen is present as unionized H gas. Let us see what temperature is required so that the maximum wavelength of emission of blackbody ionizes atomic hydrogen. Let us find out the wavelength corresponding to 2.179 times 10 to the negative 18 joules. E equals hc over lambda. So lambda equals hc over E plugging in the values 6.626 times 10 to the negative 34 joules second times 3 times 10 to the 8 meters per second over 2.179 times 10 to the negative 18 joules. That gives us 9.1 9.116 times 10 to the negative 8 meters. Now, we have to find out using Wien's law the temperature corresponding to lambda of 9.116 times 10 to the negative 8 meters. From Wien's law, temperature times lambda max is 2.9 times 10 to the negative 3 meters Kelvin. So, we need to find out at what temperature the maximum intensity would correspond to this lambda. That would be 2.9 times 10 to the negative 3 meters Kelvin over 9.116 times 10 to the negative 8 meters, which is 31,800 Kelvin. Kelvin is the temperature required to ionize hydrogen. The wavelength of 9.116 times 10 to the negative 8 meters would be found in the UV region.